All right, let's take a look and see what the consequences of this formula that we've got for guitar strings and open tubes. All right, let's just pick a harmonic. Let's say we're dealing with second harmonic. And let's see how this plays out for us. So if we look here, L is going to be equal to 2 divided by 2, V divided by F. So in general, L is going to be equal to V divided by F for the second harmonic. Let's think about it and flip it a little bit though. All right, can I put the F over here and then do V divided by L? So what's the relationship between the length of the tube or the length of the guitar string and the frequency that we hear? Well, let's take a look at some odds and ends here. This velocity is the velocity of sound, of the sound that was propagated. So if we look here, this is going to be constant as we pluck our way through that. Now, if it's a guitar string, it's going to be constant unless we change the tension or the linear density of the string. So when we're dealing with open tubes, it's really the velocity of the air, of sound in the air at 343. All right, now, let's have a look here. The relationship, F is in the numerator, L is in the denominator. What type of relationship do they have? They're opposites. So we have an inverse relationship. When the length goes up, the frequency goes down. When the length goes down, the frequency goes up. But don't we already know that? If we're playing a musical instrument, the ones that play low tones are very, very long. They're large instruments. So I went to see a band this past weekend. They had several size saxophones. So the big saxophone like this, and it's a bass sax, you do it, it goes, and he's playing it, fine. Then he gets this little one out, looks like a clarinet, and it's a saxophone, but it's this like real short little thing. It goes like, tweet, 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 tweet. Fine, okay, great. So both of the instruments played the same, they were similar instruments, but one was much shorter than the other and played different frequencies. All right, now when we look here, all right, we've got an opposite effect. Frequency goes up, that means that the length went down. Let's see if this is true. All right, now when I played this tube before, we could actually hear its tone. And notice the size of this pipe. Now I have a second pipe, and this one is longer. So notice the two different lengths. We know, because of that formula, that the frequency from this one will be higher because the length is shorter. We know the frequency of this one will be lower because the pipe is longer. Let's hear it. I'm not doing anything different. Got exactly the same thing I did, but when I played this one, the shorter one, the frequency was higher. When I played the longer one, the frequency was lower. If we can control the length of these pipes when we play musical instruments, we can actually change the notes that we actually play, whether it's a trumpet or a trombone or whatever instrument that you're playing, flute, clarinet, whatever. And that's what the valves are for, to make the tubes longer or shorter, and that's how musicians change the actual note.